At 5 in the morning, on a desert highway about 40 miles outside Las Vegas, a rented box truck ran out of gas. In the back was a machine David de Caussin had bet his family's shop on. His wife sat in the cab in tears. They were still 3 states from Chicago and the largest industrial trade show in North America, and the overloaded truck managed about 90 miles per tank. That was 1974. 20 years later, the company riding in the back of that truck would sell more than 10,000 machining centers. Van Nuys, California, 1955. A toolmaker named Francis de Caussin backed a small metal cutting mill and an air compressor into the garage of his house and started taking in work at night. He bought the equipment on time payments, on nothing but the strength of his own credit. He had trained in the automotive industry, in the plants where a man's value was measured by whether the part he handed over fit the gauge. And he had come west with a wife, 4 children, and a conviction that he could do better working for himself than working for someone else. The garage was not a business. It was a second shift. Francis worked days for other people and nights for himself, and when the sun went down, the sound coming out of that garage in the San Fernando Valley was a single mill cutting steel under a bare bulb. His sons Larry and David were still in school. They came home, ate, and went out to the garage. That was the arrangement. Nobody wrote it down. What Francis was really doing was cheaper than any of it sounds. A one-man job shop in the mid-1950s did not bid on beautiful work. It bid on whatever came through the door, at a price that undercut the shop across town, and it made its margin by being faster than the price implied. The mill sat on a concrete slab. The compressor ran off a household circuit. Chips went into a barrel. When a customer needed 20 parts, Francis made 20 parts and delivered them himself, and the money that came back went straight into the next tool. It took 6 years for that to become an actual company, and when it did, it was funded by a teenager. Larry de Caussin was the saver in the family. While his brothers spent, he put money in the bank, and by the start of the 1960s, he had $2,500 sitting there. David would describe it later without any decoration at all. Larry was always the penny pincher. He saved all his money. He had $2,500 in the bank, and his $2,500 financed a multi-million-dollar company. In 1961, the family decided to stop working for anyone else. They rented an industrial unit in North Hollywood, 800 square feet, roughly the size of a 2-car garage with better lighting, and they bought a lathe on Francis's credit. 4 de Caussin, 1 rented bay, and a customer list that did not exist yet. They needed a name. What they landed on was an acronym so plain that most of the machinists who later swore by it never worked it out. Francis, Adrian, David, and Larry. F-A-D-A-L. Fadal. The company was literally named after the 4 men standing in the room. And the 4 of them split the work along the lines of what each one could not stop thinking about. Francis was the patriarch and the toolmaker, the one whose standards set the floor. Adrian went toward electronics, toward circuits and logic, toward the parts of a machine that nobody in a 1960s job shop understood. David went toward mechanism, toward linkages and clamps, and the physical problem of making metal move metal. Larry took manufacturing, assembly, scheduling, and the money, which in a shop that size meant he was the one who knew whether Friday's payroll was going to clear. That division held for 30 years. It is the reason the company worked. For the first decade, Fadal did not build machine tools at all. They cut parts for other people, and the people they cut parts for happened to be in the most demanding industry in Southern California at the most demanding moment in its history. The aerospace corridor running through the valley in the 1960s was not an abstraction. It was Hughes aircraft. It was the satellite programs. It was landing gear and gyroscopes and structures that were expected to survive launch. Fadal took that work. Precision contract machining, tolerances that a general job shop could not hold, delivered on schedules set by programs that answered to the federal government. It also nearly killed them. In 1965, one of Fadal's significant customers, a company called Summers Gyroscope, went into Chapter 11. When it went down owing Fadal $17,000. That number needs context. A shop capitalized 4 years earlier by $2,500 of a young man's savings had just had $17,000 of completed, delivered, invoiced work turned into a line item in a bankruptcy filing. The parts were gone, the material was paid for, the hours were spent, and the money was never coming. That is the kind of number that ends most small shops, and it ends them quietly, because nobody writes an article about a 4-man machine shop in North Hollywood closing its doors. The de Caussins survived it for one reason. The work in front of them was accelerating faster than the loss behind them, because the industry they had wandered into was in the middle of the largest engineering program in American history. The most demanding of them was surveyor. Before any American walked on the moon, 7 robotic landers were sent ahead to find out whether the lunar surface would hold a spacecraft or swallow it. Surveyor was built by Hughes Aircraft, and Hughes bought parts from a network of small California shops. Fadal was one of them. When Surveyor 1 set down in the ocean of storms in June 1966 and started sending photographs back, some of the hardware inside it had been cut in an 800-square-foot bay in North Hollywood by a father and 3 sons. Hughes sent Francis congratulatory telegrams in 1966 and again in 1967. 9 years later, in 1975, Hughes gave Fadal a Supplier Zero Defects Award, which in that industry is not a plaque for showing up. It means that across a long run of parts, on a program where failure is measured in hundreds of millions of dollars, they never shipped a bad one. And it is worth sitting with what that actually required in 1966, because there was no software involved in any of it. Every surface was produced by a man turning a hand wheel. Position came from a dial and a vernier, or from a set of gauge blocks stacked to a dimension and rung together by hand. Flatness came from scraping, which means a machinist coating a reference surface with blue dye, sliding the workpiece across it, reading the high spots off the transferred color, and cutting them down with a hand scraper, a few tenths of a thousandth of an inch at a time, then doing it again and again until the print pattern came up even. Bores were held with boring heads adjusted by feel. Inspection was a surface plate, a height gauge, a dial indicator, and a man who had done it long enough to trust his own hands over the number. Zero defects on aerospace hardware, done that way, is not a story about equipment. It is a story about a family that would not let a part leave the building. But precision was not what was going to make them rich, and Francis knew it. The economics of a job shop are brutal and simple. You are paid for a finished part. Every minute the spindle is not cutting, you are paying for the building, the power, and the man, and receiving nothing, which meant the de Caussins spent the 1960s staring at machines that were, from their point of view, too slow at the only thing that mattered. So they started modifying them. Francis bolted riser blocks under small mills so they would clear larger aerospace parts, buying vertical capacity the machine had not been sold with. Larry wired a second motor onto a lathe spindle to get more torque out of it, temporarily, because the job in front of him needed it and the machine would not deliver it. David made longer handles for the manual machines so an operator could push harder into a cut. That is the entire engineering philosophy of the company in one sentence. The machine was not good enough, so they changed the machine. None of this was innovation in any formal sense. It was a shop hot-rodding its own equipment because the alternative was losing money. What it did was train 4 men to look at a commercial machine tool and see a first draft. Then, in 1969, they bought a computer. Not really a computer, but the first thing close to one they had ever owned. It was a Bridgeport mill fitted with numerical control, a superior electric control unit, and a third axis attachment, and it cost $25,000 in 1969 dollars. For a shop that had been capitalized by a kid's savings account 8 years earlier, that was a bet on the whole future of the trade. Numerical control meant the machine could read a punched paper tape and move itself. No handwheel, no operator watching a dial. You wrote the moves, the tape carried them, and the machine executed them the same way at 2 in the afternoon and 2 in the morning. For a shop doing repeat aerospace work, that was the difference between selling a man's time and selling a machine's time. In practice, it was less magical than that. Somebody still had to work out every coordinate by hand, on paper, from the print. Somebody typed those coordinates into a tape punch, one block of code at a time, and out came a long roll of oiled paper with holes in it. If you made a mistake in block 47, you did not edit anything. You spliced the tape, or you punched it again. The tape went into a reader on the side of the machine, and the reader fed the control, and the control fed the motors. A dropped tape on a dirty floor could cost an afternoon, but the machine still could not change its own tools. Every time the program called for a different cutter, the whole thing stopped. A man walked over with a wrench, loosened a drawbar, pulled the tool out of the spindle, put the next one in, torqued it down, and hit cycle start again. On a part that needed a center drill, then a reamer, then an end mill, then a chamfer tool, you had a computer-controlled machine tool sitting idle 5 times, waiting on a human being with a wrench. David de Caussin could not let that go. The problem he set himself was not obvious. Anyone could imagine an arm that swapped tools. The hard part is what happens at the spindle nose. A cutting tool has to be clamped into that taper with thousands of pounds of force because a tool that moves under load destroys the part, the cutter, and sometimes the spindle. To automate the change, you have to release that clamping force on command, hold the tool while the arm takes it, accept a new one, and reclamp it to the same force every single time, thousands of times, without the accuracy drifting. That mechanism is the power drawbar, and David spent years on it. Adrian did the electrical side, the sequencing, and the logic that told the mechanism what to do and when. What came out the other end was a bolt-on automatic tool changer for a mill that had never been designed to have one. And the thing they had actually built was not a convenience. It was arithmetic. A manual tool change on a running job costs a minute or 2 of spindle time, and it costs it every single time the program calls for a new cutter. Multiply that across 5 tools, across 100 parts, across 2 shifts, and a shop is paying a skilled man to stand next to a machine and stop it. Take the wrench out of the loop and the same building, the same power bill, and the same payroll produce measurably more finished parts per week. That is the entire business case for automation on a shop floor, and in 1974 it was still something a small manufacturer had to be convinced of rather than something everybody already knew. By 1974, they had a working unit. And then they had the actual problem, which is the problem every small manufacturer has ever had. They had built something good in a rented bay in North Hollywood, and nobody on earth knew it existed. There was exactly one place to fix that. Chicago, the International Manufacturing Technology Show, the largest gathering of machine tool builders and buyers in North America, where the Japanese and German builders arrived with freight budgets and marketing departments and stands the size of houses. The de Caussins rented a box truck. They loaded the mill and the tool changer into it, which is several thousand pounds of cast iron on a vehicle that was never intended to carry that, and David and his wife started driving east out of Los Angeles. The truck topped out at 55 miles an hour. Loaded like that, the 25-gallon tank was good for roughly 90 miles. Which means the entire drive across the desert southwest was a series of anxious calculations about the distance to the next station. They got one of those calculations wrong. At 5 in the morning, in the dark, about 40 miles short of Las Vegas, the truck died on the shoulder. No fuel, no traffic. 2 people from the San Fernando Valley sitting in an unheated cab in the desert cold, with the entire future of the family business sitting behind them in the dark, going nowhere. What saved them was a stranger in an off-road Jeep who happened to come by and stop. He drove David to a roadside gas station, waited while David bought 5 gallons, and drove him back. David paid the man for his trouble and handed him a fifth of scotch on top of it, which is the kind of detail nobody invents. They made Chicago. And then Chicago did what Chicago does to people who have never driven a truck in it. They came into the city at 5:30 in the afternoon, into the full weight of rush hour, and David took a turn onto a street with a low bridge over it. 8 feet of clearance. The truck did not fit. Behind him, a city street packed solid with traffic. His wife was crying. There was no way forward and no way to turn around, so David spent close to an hour backing an overloaded box truck out of a gridlocked Chicago street, foot by foot, in front of an audience. Larry de Caussin later put the whole decade into 6 words. "We started in pioneering times, and pioneers take some arrows. But they got the tool changer onto the floor at IMTS." And David's own summary of the trip is the least dramatic sentence in the entire history of the company. They finally made it to the show, and they met a lot of important people. That is the moment the company turns. Not the garage, not surveyor. A folding stand in Chicago in 1974 with a hand-built tool changer on it, put there by 2 people who nearly did not arrive. If you are enjoying this one, subscribe. Trade Archive covers the companies that built the tools other companies are made of, and a lot of them start in a garage and end up in a bankruptcy court. By 1975, the orders were a problem, not the absence of them. The volume. A 4-man shop in North Hollywood was suddenly being asked for a mechanism that took skilled hand assembly, and they could not build them fast enough. Which is the point at which a small company either scales, sells, or gets copied. Fadal got copied first. An English firm called Matchmaker put out a tool changer that was, by the de Caussin's account, their design. The company later apologized for it. An apology, as anyone who has ever been copied will tell you, does not come with a royalty check. Then came the offer that actually built Fadal Engineering. Summit Engineering of Bozeman, Montana, a division of Dana Corporation, wanted the tool changer, not a license. The design and the patents. They paid $75,000 for it, rebranded it as the Bandit Quick Draw, and then, because Summit could not build the mechanical assemblies as well as the people who invented them, subcontracted the work straight back to Fadal. Over 2,000 assemblies. Read that sequence again, because it is the most important business decision the family ever made. They sold their only original product to a larger company, and then got paid a second time to manufacture it. The $75,000 was the capital. The 2,000 assemblies were the production experience. And what they bought with both was the freedom to stop making other people's parts and start making entire machines. That decision seemed small at the time. It was not, because there was still one piece missing, and it was not mechanical. A machining center is 2 things bolted together. It is a rigid iron structure that moves cutting tools through space, and it is a control, the electronics that decide where those tools go and how fast. In the 1970s, the control was where the money and the mystery lived. Fanuc controls came from Japan. They were expensive, they were closed, and when one failed, a shop owner in California waited on a technician and a part that might be on a boat. Adrian de Caussin decided to build his own. Around 1977, in the middle of the tool changer boom, Adrian got a working prototype turning motors under his own control code. The computer he used to develop it was a IMSAI 8080, a hobbyist kit machine built around an Intel 8080 processor, the kind of thing that was sold in pieces to electronics enthusiasts and assembled on a workbench. It is the same class of machine that was sitting in garages in Silicon Valley at exactly that moment, being pointed at an entirely different industry. Adrian pointed his at a milling machine. And what he put into that first control was not a stripped-down imitation of a Fanuc. He wrote in cutter radius compensation, which lets a programmer describe the finished shape of a part and let the machine work out the tool path around it, and backlash compensation, which lets the control quietly correct for the mechanical slop that every ball screw develops as it wears. Those were not standard features on cheap controls in 1977. On a machine sold to a small shop, backlash compensation is the difference between a mill that holds tolerance for 15 years and one that becomes scrap iron in 6. That control became the CNC 88. It is the single most consequential thing anyone in the family ever designed, and it is the reason machinists still argue about Fadals in 2026. By the end of the 1970s then, the company had all 4 pieces in hand. They had 2 decades of aerospace precision work behind them, which set the standard. They had a proven automatic tool changer, which set the mechanism. They had a control they owned outright, which set the economics. And they had a father and 3 sons who between them covered structure, mechanism, electronics, and manufacturing without needing to hire a single outsider to explain any of it. In 1979, they built a prototype for a complete vertical machining center of their own. Everything after that is the consequence. The first machine they sold was called the VMC45. Geared head, 4-speed gearbox, a hanging pendant with a standard typewriter keyboard on it at a time when most controls were a wall of unlabeled buttons, and Adrian's control running underneath. They priced it at $110,000 against Japanese machining centers selling around $160,000. Then, the Japanese builders cut their price to $90,000. Larry's read on the situation was that the imported machines carried a lot of fat, meaning features, casting mass and margin that a small shop was paying for and never using. So, Fadal did the thing that defines the company. Instead of matching the price with a discount, they redesigned the machine to be cheaper to build. Fewer parts, a belt-driven high and low-range spindle instead of a gearbox. One control, one configuration, one way of doing everything. That machine was the VMC40, and they took it to the WESTEC show in Los Angeles in 1984, into a booth roughly 6 feet by 12. Down the aisle was a Krolak, one of the established names, with a stand the size of a small parking lot, an upside-down mill suspended 40 feet in the air, and Los Angeles Rams cheerleaders working the crowd. The de Caussins had a folding table. David's running joke through those years was that they would have a nice auction someday when they went bankrupt. Later in the show, Fadal's people overheard an acrolock man standing at their control, looking at the screen, calling it the control of the future. A Krolak's booth got smaller every year after that. What made the machine survive is worth understanding because it is the opposite of how you would build a cheap machine today. Fadal built on cast iron boxways. Instead of running the moving axes on hardened steel rails bolted to the casting, which is cheaper and faster to assemble, they cast rectangular ways directly into the iron, ground them, and then had a man hand scrape the mating surfaces the same way Francis had scraped aerospace fixtures in the 60s. Onto those scraped surfaces went a non-metallic liner, so the table slid on a low-friction bearing surface with the entire mass of the casting behind it. Heavy, damped, and slow to wear. Exactly what a shop cutting stainless and titanium 10 hours a day needs. Then they made every part of it replaceable by the customer. The spindle was a self-contained cartridge, so a shop with a dead spindle pulled the cartridge and dropped a new one in instead of shipping the machine anywhere. The circuit boards were modular and sat in an accessible cabinet, and Fadal built those boards themselves rather than buying a control from Japan, so a burned-out Axis amplifier was a board swap, not an international phone call. And they refused custom orders. No special colors, no customer-specified controls, no one-off configurations. Larry's reasoning was purely about service. Custom machines are a nightmare to support. If every machine in the field is the same machine, a service technician can carry every part he might need in the back of his van and fix any Fadal in the country on the first visit. At its peak, the plant was building 10 machining centers per employee per year. One of the earliest customers for that VMC40 was a man named Gene Haas, who was making rotary indexers at the time and needed to cut parts for them. He bought a machine somewhere around number 25 off the line, and David personally spent 3 days at his shop training him on it. A month or two later, Fadal's salesman came back with a report. The machine was in pieces all over the floor. Fadal's response, in David's words, was to decide it best to limit Gene's visits to the factory. Haas Automation introduced its own first vertical machining center in 1988 from a building in the same valley. For the next 20 years, the two of them, friendly competitors by every public account, would between them account for roughly 2/3 of the American machining center market. Through the boom, Fadal moved into Chatsworth and kept growing until the operation ran across multiple buildings and employed around 370 people. Gladys de Caussin, Francis's wife, served hot soup to the workers at the 9:15 break. That tradition survived the family's ownership of the company. A machinist named Ralph Eifley, who joined in 1963, said the thing that made the place what it was had nothing to do with the machines. If a man got into a jam, he could go straight to Dave or Larry, and they would loan him the money. He also called David one of the smartest engineers he had ever met, and noted that David had no formal education at all. By 1995, Fadal had sold 10,000 machining centers, and then they sold the company, for the least romantic reason imaginable. Taxes. Everything the family had was inside the business, in property, machines, inventory, and receivables. Handing it to the next generation meant a gift tax on top of income tax, and the arithmetic came out at roughly 25 cents on the dollar. To pay a tax bill like that, the heirs would have had to liquidate the thing they were inheriting. Rather than force a fire sale later, Larry and David sold in April 1995 to Giddings and Lewis, then the largest machine tool builder in America, for $180 million. Larry's son Dean stayed on to run it. At the end of December, Larry and David retired. 2 years later, Giddings and Lewis was a target. In April 1997, Harnischfeger Industries launched a hostile all-cash tender offer at $19 a share. The board fought it, went looking for a friendlier buyer, and found one in the German conglomerate Thyssen, which came in at $21 a share. That offer closed on the 30th of July 1997, with roughly 97% of the outstanding shares tendered. In 1999, Thyssen merged with Krupp. So a family machine shop from North Hollywood became a line item inside ThyssenKrupp, then passed into a Siemens metalworking orbit, where there was a documented push to replace Adrian de Caussin's control with a Siemens Cinemeric unit on Fadal machines. Then it went to MAG Industrial Automation Systems, under Mo Madar. Each owner further from the shop floor than the last, and each one convinced that the control the customers loved was the part that needed replacing. Around 2008, MAG discontinued the machines and liquidated what was left. The Chatsworth plant closed. The building eventually became indoor storage for recreational vehicles. But there were tens of thousands of Fadals still cutting metal, and they had been designed from the beginning to be kept alive by the people who owned them. So an entire aftermarket grew into the gap. Independent Technology Service, chosen by the family back in 1992 to test and repair Fadal boards, is still doing it. Glenn de Caussin, David's son, founded a company called CalMotion that builds a drop-in replacement for the original control, a card that keeps the iron and the wiring and swaps the brain, with processing power his own description puts at 20 to 30 times the original. A 30-year-old Fadal gets Ethernet, faster block processing, and another decade of work. The name came back too. In July 2014, Merrill Technologies Group, a family-owned manufacturer in Saginaw, Michigan, relaunched Fadal Engineering and brought a new line of machines to the same Chicago trade show David had nearly failed to reach 40 years earlier. Their chief executive, Robert Yackel, said the founding family of Fadal had been a lot like his own. Entrepreneurial, hard-working, resourceful, and determined. In 2024, the brand changed hands again to Troy Alwyn, who had started with Fadal's Illinois distributor in 1989 as a service technician. Fadal Engineering today operates out of West Chicago, Illinois, still selling vertical machining centers, still using the model numbers. David de Caussin, meanwhile, spent his retirement posting machining videos from his own shop, designing tap holders and showing people how to do things with their hands. That was the story of Fadal. If you find stories like these intriguing, there are plenty more on the channel. And the next one is already on screen.